Hello, let's do the New York Times Hard Sudoku for January 3rd, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, we do have two ones here. That's a one in one of these two cells. We have two fours as well. Okay, so what we've done here is we've corner marked the ones and the fours into the same two cells. What do those mean? Well, if you think about it, it means one of these two cells is a 1, and one of these two cells is a 4. Well, the two cells can only fit two digits, and we know one's a 1, one's a 4. That's called a hidden pair. We can't put anything else into those cells. So we can mark them as a 1-4 pair, center marks. And we also know that any other digit that we thought could go there actually can't go there. So the immediate thing I'm seeing is this 9 now. This 9 looks in, this 9 looks up. And this hidden 1-4 pair can't be a 9. Neither can this 2. So you can think about it. The same reason this 2 can't be a 9 is the same reason this 1 and this 4 can't be a 9. We just don't know what order they go in, but we know they're going to go in one order or the other. So these can't be 9 either. Might be a good way to think about that. They're all but placed. We just don't know the order. And so the 9 ends up here, and then these two 9s look into here, putting a 9 in one of these two. This 7 and this 7 look in, placing this 7, and now these two 7s look into here with this 7, placing that 7. Let's keep following up on 7s. 7 in one of those two, 7 in one of these 3, and I don't think there's much with 7s. Oh, actually, we can place this 7. Okay, let's just keep going with 7, 7 in one of these two. All right, we can't quite resolve this, but there's just 3 7s left to place in this bottom band. That's it. All right, so we did 1, 4, and 7. We did 1, 4, 7. We did 9. So let's just do these digits. The 2. So little mental note that the 2 is limited to one of these 3 cells. So is the 9. The 9 can't be here, but it doesn't matter. If I highlight these 3 cells, one of them is going to be a 2. One of them is going to be a 9. This is where I look for a third digit that's limited to the same cells, and there's not really any good candidates for that. This 4 is already placed. The 1, the 7, and are already placed, and 2 and 9 are part of my triple already. So we're not going to get another one limited to those 3 right now, but it's something worth at least trying to remember. I'm not gonna corner mark it. I don't like corner marking around a corner. It confuses me. It makes me think there's pointing when there's not. I've made too many mistakes doing that to ever actually do it on purpose. All right, so this 3 looks up into here, placing the 3, and our final digit is a 5, so we can follow up on those as well. So that was the 2. I wonder if this 3... So the 3 almost. The 3's in one of these 4. Right, there's a lot of stuff we can look at, but let's just go through each digit first. This 3 and this 3, though. That's actually nice. There's a 3 in one of these 2. That points in here along with this 3. Putting a 3 in one of these 2. So that was 3. We also have the 5. This 5 and this 5. Put a 5 in one of these 2 cells. This whole top band, I think, is going to get some more good stuff. We got a lot of 5s going on. Let's just take a quick look at that. Because I'm noticing 5s are here. 5s are down here. I think that's really all. Oh wait, get out of that. Oh wait, no, 5 is placed in this box. And that places the 5 here. Okay. So we know the 5 is in one of these 2 cells up here. Okay. I think that's all we get out of 5s for now. There aren't that many 5s left. So there's these 5s, there's these 5s, and there's these 5s. Yeah, okay. Wait, 5s look juicy, so I want to have to just follow up on them. 6. Okay, 7. Oh, we got the 7s already. The 8. Okay, so this 8 looks in, this 8 looks up. That puts an 8 in one of these 2. That is going to point down along with this 8, putting an 8 in one of these 2. This cell is looking quite restricted. In fact, this should be a naked single because it's not 5 or 8. So what is it? Well, if we just look at the row has 1, 2, 3, 4. We need a 5, but it can't be 5. We need a 6. I believe that's what it's going to be, and it can't be 8. Yeah. So this is our naked 6. And then we have a 5, 8 pair here for this row. Did I go through everything? I didn't do the 9 yet. Wait, no, we took care of 9s already. Okay. So now this row is down to 3 digits. And we know this one's not a 3, so it's quite limited. We need a 2, 3, and 8. So if I put in 2, 3, 8, that's not 3, that's not 2, that's not 8. So it doesn't let us finish the row, but it's very limited. This row is down to 5 digits. I don't know that I want to look at that yet. Let's see if we can just naturally complete this top band without penciling all this stuff. So let's just move on to the next band here. So 7s are done, 5s are done, 9 needs to get marked here. 9's just up here. So 5, 7, 9 taken care of. We do have 2 4s here. It's a 4 on one of these two. Now when I mark those 2 4s, I try to always, although someone points out every video where I missed it, it's very easy to miss it. But I try to look for, like I marked these 2 4s, I try to look at the other 2 sort of perpendicular boxes. So because these 4s are marked horizontally, I look at the vertical boxes. And I see that in box 1, the 4 is also limited to the same 2 columns. And so as a result, what that means is we need to find the 4 in column 3 here, because we know the 4 in column 1 and 2 are here and here. We don't know what order they go in, but they're going to be here and here. And so that means the 4 in column 3 isn't here and isn't here in these boxes. So the 4 ends up down here. And the effect that this has is called claiming, because this column needs a 4. It's going to be in one of these 3 cells. All 3 of those are in box 7. So this will be the 4 for box 7, meaning we can't have another 4 in box 7. None of these are going to be 4. Another way you could think about that is we only get 2 4s in these 2 columns. We know one of them's here and one of them's here. That's all of our 4s. We don't get any more 4s in these columns. But you can, thinking about it via the claiming, I think is the more traditional way to consider that. I am noticing we only have 4 digits left in this column, and I know this is markable because it's not 4. Let's just think about what they are, though. We need 1, 2, 4, and 6. So this is actually just 1, 2, 6, unfortunately. This can't be 2, so it's 1, 4, 6. But yeah, not super useful. All right, so that was the 4s. 5, 7, 9. Yeah, there's not really anything else to look at here. Just a lot of 5s, 7s, and 9s. And 4s. Okay. So this formation, though, is interesting, perhaps. Unfortunately, it's not, because we only have 4, 5, and 7 here. But if anything looks down through here or looks through here, that would limit that digit in a really nice way in this box. The other thing we can look at is stuff like, okay, 5, 7, and 9 aren't here. We already have a 5, and we already have the 7 marked. But where does 9 go in the column? We actually see we have these 2 9s actually looking down. And that actually informs us that we have this hidden 7, 9 pair here. You could do it through the box, or you could do it through the column, either way. But seeing this 7, 9 here. And so then the question is, okay, we have 2 and 6 looking in here. And so we know 2 and 6 are limited somewhere in these 3 cells with a 1, 4. So these are 1, 2, 4, 6. The 4 can't be here, though, so this is 1, 2, 6. These 3 digits will end up here. And so they have to be from 1, 2, 4, 6, and this one's not a 4, right? So, okay, this hidden 7, 9 pair, let's think about what that did. What did it remove? It did remove a 1 from these 2 cells. So we want to think about 1 in the box, we want to think about 1 in the column. Unfortunately, we don't really know much about that, so that's not helpful. It did not remove 2, it did not remove 3. It did not remove 4. We had that claimed already. 5, 6. It removed 8 from these 2. So if we look, we see this 8 looks down, and these can't be 8 anymore, and this 8 looks in. So we can place 8 in the box. This is the kind of follow-up that you want to do on finding stuff like hidden pairs. So 8 ends up somewhere in here. And then now this column is down to 4 digits, and this column is down to 4 digits. If you just basically say, well, we kind of know where the 7, 9 go in the column, so we don't have to worry about that. So I want to think about these 2 columns as well. So this is 1, 2, 4, 6. This can't be the 2 or the 4. So this is 1, 6 only. That's interesting. The 4 claimed, the 2's in the row. And then this column, we need 1, 3, 4, 8. 1, 3, 4, 8. So we know the 8 is somewhere in here. These can't be 4, so these are 1, 3, 8. Not super helpful. All right, let's take a look at this bottom band here. So 3 and 5 are here and here. So we need 3 and 5 down here. We already have the 5s marked, but we can mark the 3 as well. Unfortunately, we don't have a 3 in this column. Otherwise, we'd have a hidden pair, but we don't get that. The pointing here is the 8s. I'm actually kind of curious in this box what digits aren't accounted for, because we have a lot of corner marks here. So we haven't accounted for the 2 via corner marks, which we know is in here somewhere. We have the 3, 4, 5, 6, 7, 8, 9. So it's just the 2. So yeah, I can just add 2 to these corner marks. This is 2, 9. This is 2, 5, 9. Okay. I don't think that immediately helps, but I think it's good to have those marked to try to find pairs and triples later. All right. What else is going on here? So we did the 3, 5, the 3, 5. We have the 2 here. But that does not appear to... Actually, the 2 ends up in one of these 2 cells. So this can't be a 2. That's a 1, 6 only. It doesn't immediately do anything. Okay. This row is down to 1, 4, 6, 9. Okay, where's the 9? Because this 9 sees here. So the 9 can only go here in this row. And that seems to do a lot of good, because that places the 9 in this box, which then places the 9 in this box. Are we done with 9s? Not quite. Oh yeah, we get the 7 and the 9 here. And we're still not done with 9s. We should be able to place the final 9. I think there's just one more. Yeah, the final 9 ends up here. That does not place the 8. There's still 2 places for 8. But we did finish 9, so that's nice. So that was this. This is 1, 4, 6. Can't be 1 or 4. So this is a 6, giving us the 1 and the 4 here. So this is a 4 and a 1. That places the 4 in this box. Yeah, we know that this had to be a 1, 2, 6 now. Because remember, it was these 3 digits go here, and neither of these can be 1. So the 1 ends up there. Well, okay, this is 2 and something. 2 and 6, it looks like. Okay. Nice. Got some good stuff. Let's follow up on it. So this box is full now. I got this 1. 1s are done. I got this 4. I don't think any of that helps. I think we just had this 1, 4 pair left. Is that right? I don't know if I placed anything else. I'm not seeing anything. I hope that's the case. I hope I'm not missing something easy. All right, we got a bunch of these. We got this 6 and this 9. We know 9s are done. What does this 6 do? Not much. We do have 2 6s looking in here now. Okay, so I missed this 6 getting placed, I guess, at some point. 6 is in one of these 2. 4, 5, 7. Unfortunately, these match. And so do these. It's very annoying. Keep wanting to do something with that. These 2 digits are limited because they're not 7, 8 in addition to these 4 digits. If you just count, that's 6 digits they aren't, so there's 3 digits max that they are. And that's going to be the 1, the 2, can't be 3, could be 4. Can't be 5, 6, 7, 8, 9, right? So this ends up only 1, 2. This 1, 2 will end up over here somewhere. So this is one of the digits that goes here, and this is the other one. Don't know what they are, but... So 1, 2, 4, 8... How about these 2 digits? Because they aren't the 3, 5, or 7. So they could be 1. They're not 2. They're not 3. They could be 4. Oh, neither of them can be 4. What's going on with 4s in this box? Okay, well, that's very helpful. There are 4s in one of these 2. That makes a hidden 4, 7 pair. You don't have to care about this 3 here. 3 is one of the digits that gets eliminated by the hidden 4, 7 pair. This can't actually be a 3, and that makes this a hidden 3, 5 pair. Remember I said I wish this wasn't 3, so I can make a hidden 3, 5 pair? Anyway, so now we're down to the 1 gets placed, and then the other digit gets placed, whatever it is, the 6. And that gives us the 2 and 6 here. Very nice. Okay. So 3, 5, 4, 7. This 4, 7 affects the column. We're down to 1, 2, 3 here. The 1 has to go there because of this 1. This is down to 2, 3. This column is... We know this can't be 8 because the 8s are pointing down. So it's 3, 5, and something else. 3, 5, 6. It's not a 5. The box. 2, 6, 3, 6, 2, 3. Interesting. Maybe I should look at this column as well. I need 2, 3, 5. Wait, what did I miss? 1, 2, 2, 3, 5, 8. 2, 3, 5, 8. Oh, 8's even marked there. 2, 3, 5, 8. So this is 2, 3, 8. And this is 2, 3, 8. Yeah, 5 is here. So that's a 2, 3, 8 triple. What's the digit that's missing here? The 6. We need a 6 in this row, which ends up right here. How'd that happen? Oh, because 6 in this box is here, which I didn't notice. All right, so that's 2 and 6. That's not a 6. That places the 6 here. 6s are done. Wow, that's surprising. All right, anyway, 2, 3, 8 here for the row. This row is just a triple, though. So this should be a single. So we need the 1. We have 2. We need 3. We have 4, 5, 6, 7. We need 8. And so 1, 3, 8. This is our 2. Right, the 2 looks in. That's our 2. Okay, nice. The 2 gives us the 1. And so now the 1 in this box goes here. Notice that this digit ended up there. This digit's going to end up there. It's 3, 8 for the column, but it can't be 8. So it's our 3, 8, and 3. So yeah, like I said, these 2 digits ended up here. For what it's worth, we didn't have to use that, but it did end up being true. 2, 4. Okay, what am I going to pencil? 2, 5, 8 here. Can't be 8. Can't be 5. So this is our 2, 8, and 5. That's our 5, 8, 3, and 2. We get our 3, 8, and 2 here. We get our 3 and 5 resolved. We get our 8 and 3 resolved. This 3 in the corner emits snow for us. We get our 8 and 7. This can't be 7, so that's 4 and 7. That's 2, that's 4, and we're done. Alrighty. Cool. This puzzle had some interesting like hidden pairs and stuff. I think that was neat, especially this box. I liked the 4, 7 and the 3, 5, which resolved the 1, 6. That worked out really nicely, and I think that kind of resolved the rest of the puzzle for us. The top band had some nice stuff that resolved as well. Middle band was frustrating because it was all the same givens. Couldn't do much with it. But yeah, pretty neat. All right, I enjoyed that puzzle. Let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.